All right, now that we have seen the transformations and kind of what they do, we are going to do some more examples. This first one, we're going to describe the transformations, and remember we're basing it off of our a, f of x minus c, and h. Oh, not h, plus d. All right. Oh, and then we have b of x right there. All right. Describe the transformations. We don't have an a value. We don't have a b value. We have a c value. So remember, if c is positive, we are going to move to the left. So we're going to shift left 1. All right, and then we have a d value. It's negative. Negative d is going to be down. So we're going to shift down 4. And that's it. You're just describing the transformations. All right, next one. We do have an a value, and we also have a negative out front. So remember that negative out front is going to be a reflection on the x-axis. I spelled that totally wrong. All right. And then our 1/2 is our a value, and it's less than 1 because the absolute value of negative 1/2 is 1/2, and that is less than 1. So, and it's greater than 0 as well. So that means it's a shrink. So vertical, because it's on the outside, shrink of 1/2. Next, we also have a negative on the inside, so it's also going to reflect on the y-axis. And right here, since we have a negative with x, we're going to have to do a little bit of solving to know if we're going right or left. So we're going to take what's inside, set it to 0. So we add 2, so we think, oh, we might be going right 2. But we have that negative in front of x, so that affects your right and left. So whenever you have that negative in front of x, it will change that value. So we divide by the negative, so x equals -2. So that means we're going to shift left 2. So be careful, those horizontal ones can be tricky, especially if there's that negative in front. All right, let's look at graphing these. So we have an a value that is going to stretch our y values. We have a -2, so this is a reflect on the x-axis. And this is a stretch, a vertical stretch of 4. This will be right 2 because we don't have a negative with our x, so we just add 2 to the other side. So right 2, and then we are up 2 as well. It is an x squared graph, so I am going to graph my parent function. And it's going to be in black. I was trying to do it dotted, but can't really do that. So we're just going to graph it in black, and I keep messing up the line, so it's not matching up to our points correctly. All right, so that's our parent function of our x squared graph. It's through 0, 0, and then at 1 and 1, a negative 1, it's also at 1, then 2 and 4, and negative 2 and 4, because they match up on those sides. So we have 0, 0, and then I'm going to apply our transformations to those numbers as we go. But first we'll see where we move first and kind of look at the graph that way. All right, then we have 1, 1, negative 1, 1, 2, 4, and then negative 2, 4. All right, so let's look at the points here. We're going to do that in red. So I'm going to look at the transformations first. So we are supposed to go right 2 and up 2. So right 2, up 2. And then sorry, the video was being weird. The points are then supposed to be stretched by 4 and reflected across the x-axis. But that is our starting point. Your left and right, you always do your origin point by your left and right. All right, so let's look at our actual points. So remember, we're going to be adding 2 because we're going right for our x's. And then for our y's, we're multiplying by a negative 4 and then going up 2. So multiply by negative 4 and then add 2. So that's going to be 0 plus 2, which is 2, and then 2 plus 0, which is 2. So 2, 2, that's where we ended up. All right, let's look at 1 and 1. So we're going to add 2. So that's going to be 3. Then this one we're going to multiply by negative 4 and then add 2. So negative 4 plus 2 is going to be negative 2. So at 3, we're at negative 2. Next, we're going to do this. 2 plus negative 1 is going to be 1. And then negative 4 plus 2 is going to be negative 2. At 1, we're at negative 2. And remember, those should be reflected across each other because our x squared has those points that reflect. All right, next one we have 2. So add 2. That's 4. And then multiply by negative 4 and then add 2. So negative 16 plus 2, which is negative 14. So 2, negative 14, or our 4, and it's going to be way down here. Like we said, we were going to end up way down here. All right, and then next, so negative 2 plus 2, that's 0. And then negative 4 plus 2, that's going to be negative 16 plus 2, which is going to be that negative 14. So it's going to be that down again. So it really stretches those values apart on the y-axis to where we're going to those really negative points really fast. All right, next one. Looking at our transformations, it's a 1/2, so it's smaller than 1, so it's going to be a shrink. We don't have any negatives in front of our equation or in front of x, but then remember we're going to minus 1, so that's going to be left 1 and then down 4. And then our parent function is our square root of x. So that should be here like this. All right. For our transformations, so we have 0, 0, then 1, 1, and then 4, 2. Those are usually your points for your square root graph that you want to have. for our left and right. So we are going to go to the left 1 and then down 4. So that is going to be our starting point. And then our values from there will be left 1, down 4, and shrink by 1/2. So let's look at that. So 1/2 goes here and then subtract 4. So we're going to multiply. And then this one we are going to subtract plus a -1. We'll do that so it doesn't look too weird. All right, so this would be -1, and 0 times 1/2 is 0. 0 minus 4 is -4. So that's that -1, -4. That's your origin point. Next one, we have 1 plus -1, which is going to be 0. And then 1 times 1/2 minus 4. So we have 1/2 minus 4. If we turn 4 into a fraction by doing 2/2, that's going to be -8/2. Which will be -7/2. So at 0, we're at -7/2, which is 3.5. So kind of in between 3 and 4. All right, next one we have 4 plus a -1, so that's going to be 3. And then 2 times 1/2 minus 4. So 2 divided by 2 is 1. 1 minus 4 is going to be -3. All right. So at 3, -3 is our next point. All right, so if we connect those dots together, it kind of makes it more of a flat line. Let me see if I can curve that a little bit better here. So it flattens those points out or stretches them. Nope, shrinks them closer together. So it's going to shrink that graph so it's closer to like a flat line, which is our x-axis. Remember on our other one where it shrunk those values closer together. So our y values are really close together instead of farther apart like this one, like our parent function. Up next, we're looking at a graph and determining where we shifted and then writing an equation based off of those transformations. We are looking at that x to the third graph, and we're looking at our points to see how they shifted from that x to the third function. So remember, x to the third starts at 0, 0, and it goes down on the left and up on the right. So we're wanting to see where from 0, 0 did we get that new point, that 3, -2. So it looks like we went to the right 3 and then down 2. And also you notice we're supposed to be down on the right and up on the, down on the left and up on the right, but for our blue graph, we're up on the left and down on the right. So that means we did do a reflect on the x-axis. So that means our a value is going to be negative. So we know we'll have a negative out front for our new equation. All right, let's compare our points. and see if we can get back to that original function without needing to find our a value. So remember, we're going to be using x to the third. So it would be your a x minus c to the third plus d. Well, we know c is going to be 3 and d is going to be -2. So x minus 3 plus, minus 2. So that's kind of a base equation that we're looking at, and we'll see if that rings true for our points. All right. So now we're going backwards. So we have 3, -2, 4, -3, and 1, 6. We're going to apply those transformations. So write 3, so that means we're going to subtract 3 because we're going backwards. And then from 4, so we'll add that -3 because we're wanting to get back to 0. So 1, 2, 3. So we have to subtract 3 to get back to that 0. All right, for the y's, we're going down 2, so that means we're going to add 2 because we want to go up 2 to get to 0. So adding 2. Sorry, it did something weird. So we had our -2, -3, and 6. Then we added our 2. And then we have to do the reflect. So we will times it by a -1. So -2 minus 2 is 0. 0 to -1 is 0. -3 plus 1 is -1. -1 times -1 is 1. 6 plus 2 is 8. 8 times -1 is -8. All right, and then 3 minus 3, that's going to give us 0, 1, and -2. All right, so let's plot that here. So 0, 0, so that's good because that's where we needed for our starting point. And then 1, 1, and then -2, -8. So that's going to be down here. Now you can check that in your original parent function. So f at -2, -2 to the third is going to be -8. And then f at 1 is going to be 1 to the third, which is 1. So then you just sketch that. So those points match up. So we actually don't need to find our a value because our points are correct. So whenever your points are correct, you don't need to solve for your a value because it will just be a 1. So then your equation should be -x minus 3 to the third minus 2. Next one, we have our absolute value graph. And we're wanting to see getting back to that 0, 0 point. So let's look and see how we moved. So we went to the left only by 1, and then we went down 2. Left 1, down 2. So that's all we can glean so far from just the graph. It does look like we may be stretching or shrinking because it looks maybe a little bit different than our parent function should look. Because remember, our parent function is maybe a little bit wider than that graph. So we probably will be having to find our a value. But it is positive, it's pointing up and up, so we don't have a negative in front. So it should be our a, because we most likely will have a value, and left 1, so that's going to be plus 1, because remember we do the opposite for x's, and then down 2. All right, let's look at our points. So we have -1, -2. Then we have 0, 1, and then -3, +4. All right, so that -1, -2 is our origin. So we want to go left. So we actually want to go right to get back to our 0, 0. So we're going to add 1. And then we need to go up. So we need to add 2 on this side. So 0 and 0. So that one works. So that's okay. Let's look at 0 and 1. So we add 1, which is 1. Then we add 2, which is 3. Now, our parent function, if we put in 1, we should get a 1 out. So we can't get a 3. The x's is right. So that means we do have a vertical. It is a vertical stretch or shrink. It's most likely a stretch because it is a skinnier graph. All right, so we will be using our points here to help us solve. You can choose any of your points to solve for your a value. Oh, sorry. Okay, so we have y equals a, x plus 1 minus 2. Let's choose that 0, 1 point. That way our x is 0 and our y is 1. It makes it a little bit nicer to solve. But you can, any of the points will work. So you can choose any of them. And you just plug them in for x and y. Remember, this is x and that is y. We'll have 1 equals a, because we don't know what a is, 0 plus 1 minus 2. So that's 1 minus 2. So we're going to add 2. My computer doesn't like it when I get closer to the bottom. All right, 3 equals a, and then absolute value of 1 is just 1. And then a times 1 is just a, so 3 equals a. So it is going to be a vertical stretch of 3. So vertical stretch of 3, or by a factor of 3. So we'll replace our a with a 3 for our equation. And then we can apply that to our points. And the way you do it, remember we're going in reverse to get to our equation. So we're going to divide by 3. All right, so let's check our last point. So we're going to add 1. And then plus 2. So we get 6. And then divided by 3 equals 2. So at -2, we're at 2. And that checks because if we do absolute value of -2, it is going to be a +2. So just make sure you are checking for those a values because sometimes they won't work out. So always look at your points and see if they're matching in the original parent function. The cool thing about transformations is they work no matter what the original function is. We can even start with some funky function like this, where it looks a little weird, Looks like it's multiple absolute value graphs put together, but transformations will still work. So let's look at our points here. Let's list those because that will help us with our transformation. So let's label all our points here. So our first point we come to is -2, +1. Then we have -1, -1. Then 0, 2, 1, 1, 2, 3, and 3, 0. And it has that listed down there too. So let's go ahead and write those in the original points column now. So -2, 1, -1, -1, 0, 2, 1, 1, 2, 3, 3, 0. Given the function above, describe the transformation in the correct order, create the table of values, and sketch the transformed graph. All right, so we have a reflection on the x-axis, and then a vertical stretch by 2, and then right 3, and up 4. All right, we're going to be looking at our points now, and we're going to apply the transformations. So at -2 and 1. So reflect on the x-axis and vertical stretch by 2. So times by -2 and then +4. All right, this one, -2, we're going to go right 3. So we're at 3 plus -2 is 1. -2 plus 4 is going to be 2, because 4 minus 2 is 2. So we're at 1, 2. Right, next one, -1, -1. So reflect and multiply, and then add 3, add 4. So 3 minus 1 would be 2, and then -1 times -2 is +2, so we'll be at 6. So -1, 6. Oh, I'd erase that point. -1, 2, 5, 6. And then this one was at 1, 2. All right. Next we have 0, 2. So add 3. And then -2 plus 4. All right, so -2 times 2 is -4. -4 plus 4 is going to be 0. So we're at 0, 0 for this next one. All right, 1, 1. So we'll add 3. So we get 4 for this one. And then -2 plus 4. So 4 minus 2, that's going to be a 2. Notice those points that were at the same point, they're also at the same point again. So 2 and 2. So 1, 2. Oh, but this one is at 4, 2. Not the same point. So 4, 1, 2, 3, 4, and up 2. All right, next one. We're at 2, 3. So add 3, we get 5.
So -6 plus 4, we're going to get a -2. So at 5, 4, 5, and then -2. And then the last one, 3, 0. So we get 6. And then just 4. So 6 and then 4. So 1, 2, 3, 4, 6, 1, 2, 3, 4. And then we connect our dots. Okay, I fixed the dots where they should go. And now you connect the lines, or connect the dots to make the lines. And there we go. It doesn't quite look like it because of that stretch, but you can kind of see it. It looks similar. If we flipped it upside down, you would be able to tell better, or if like they were lined up, they would kind of look a little bit better. Also, this graph is scaled differently than that graph, so it does not look proportionate to the other graph. But as long as you did your transformations correct, your graph should be good. So we're making it look a little bit nicer there. All right. Last thing, we can also write an equation of a function if we know what transformations are being applied, kind of like we did when we were looking at the graph and going backwards, but this time we don't have a graph to look at, we just have the transformations. It says, write the equation of the function after the following transformations are applied in order to the graph of f of x equals x squared. And remember your basic equation. All right, we have a vertical shrink by a factor of 1/2, reflect across the x-axis, and a shift up. So we know our 1/2 is going to go first with that negative in front of it. And then we have x squared. We don't have anything to add to it. And then plus 4. You don't really need parentheses on this one since you're not having anything inside with x. So it could be just -1/2 x squared plus 4. And that's your equation. You just apply them to your values here. So our 1/2 was the a, along with the reflect, and then the shift up was our d value, so that plus 4. Right, that is it for the video. If you have any questions, please let me know. Otherwise, you will work on your assignment.